Shade.
Make you sad? You should be sadder.
Okay, so we're going to talk about how to graph y equal to x squared first. What happened?
Benjamin says the covers now means view of sight.
Okay, so y equal to x squared. So hopefully you guys know how to do this because we're going to talk about Precalculus. So this is the first one of the first graph. We know y equal to x already. We know y equal to x squared. We don't know y equal to x squared, so I'm going to show you how that graph goes. So it's going to be x, y. We're going to talk about a lot of things. X, y is going to be -2. It's going to be, I plug in -2 squared. That's equal to 4. -1, -1 squared. That's equal to 1. 0, 0 squared. That's equal to 0. 1 and 2. So that's going to be 1, 4.
No, that's y because y is the alpha, right?
So this is the table, right? So this is at this point, this is 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 actually the third point, this is actually the third point, so the parabola of this. Okay, so that is the first one of the first graph that you learn in Algebra 1 and Algebra 2. Okay, now for the third time I'll teach you properly. So we're gonna understand some character about this one, also vocab about this one. This point is called a vertex.
No way.
Okay.
Indeed.
And there is also another thing is called, what is this line called?
Axis of symmetry.
Thank you, axis of symmetry.
Yeah.
Axis symmetry. So axis symmetry is right in the middle. It's like your face. Your face is probably a true representation of your parabola. Most of the face are parabola. Okay, so that there's a line of axis symmetry. You know, your ear should be on the same level. Okay, in general, nobody's face are perfectly symmetrical, but in general, the location of the eyes, it should be exactly same spot. Your earlobe is not going to be one side higher, one side lower, so it's going to be also symmetrical from both ends. So if you have one earlobe here, you're going to have one earlobe on the other side. So that's called correspondence. So this point is correspondent to this point. This point is correspondent to this point. They are equal distance. So they are equal distance from here to here. Do you see that?
Yeah.
And do you see this equal distance? So your ears to your nose are exactly same distance from your nose to the other ear. So that's very important for you to understand when we're graphing parabola. Any other thing you need to understand is this. Parabola is actually making a lot of money. Which game that you can think of that deal with parabola? On the iPhone game. One of the first games that come out on iPhone.
I thought it was like the first game ever. I was gonna say
One of the first iPhone game is Angry Bird.
I never played that game.
Okay, so the Angry Bird, remember that it's actually very interesting about Angry Bird. The Angry Bird has, they actually, if I show you image of back in the day, I make a video. If you go back and look at my old video about parabola, I actually show the Angry Bird on the screen, and I actually show them that they actually make fun of the Angry Bird. They make fun of parabola a lot. So usually like there was something like this, right? There was a shooting the Angry Bird and you hit something right here, and that's a parabola shape. But what's funny is on Angry Bird, a lot of games they were like the background is all in like a warehouse and stuff like that.
Yeah.
And there was a chain like hanging that's in the parabola shape. So they kind of making fun of that parabola. It's like, yeah, we knew math and we make a lot of money on you. and they kind of illustrate that in the background, which is very, very interesting. That they actually make fun of the whole idea about using parabola to make money. But they actually generate a lot of money because back in 10 years ago, when I first introduced my students as showing the Angry Bird in a video, if you go back to watch my old video, you can actually see it. I show the Angry Bird screen, and I show them where's the axial symmetry when I actually play with it. But I don't have time to do that and freak out. Yeah. Somebody have questions? Yes.
So what you're saying, if we don't understand this, just play Angry Bird?
Yeah. Okay, so basically, that there is an axial symmetry. You have to understand there's just symmetry, which is hit the vertex. Exactly when they hit the vertex, that's very, very important. So this one, how is this one related to everything? So let's start by talking about what is y equal to x minus 1 squared. What does y equal to x minus 1, minus 2, let's do minus 2 because that's taking more difference. So what does x minus 2 look like? What did the graph do? Yes,
There's 2 spots to the right.
2 spots to the right. How do you know this?
Because it's inside the parentheses.
Because of the transformation rule, right?
Yeah.
If it's inside the parenthesis, that whole graph, the whole point, all the turning point is moving right 2 units. Because inside parentheses is opposite direction, so the graph's gonna be end up to be like this. Exact same units too, same units, same increases, right? And then same increases here, so it's gonna be a parabola look like this. So this one becomes this. Are we okay?
Yeah.
Is that too fast? Rihanna, are you paying attention? Oh, you know, get a paper out. Come on. Okay, so how about, let me just move up a little bit. Let me just say, hey, I'm going to erase all the graph. I'm going to grab a new graph, a parabola, and then we're going to name, so we learn how the transformation works. So let's say y equal to x minus 1 squared plus 2. So we're going to graph this function. So do you know what a graph do, and how does that graph translate? But then we're going to ask a lot more. Ariana, what do you think graph do? Are you okay? Are you sure? You want to step outside? No? Okay. Nicholas, what happened?
The graph moves to the right once, and then it moves
Up to. Move 1, right, and up to.
here.
So the coordinates is going to be exactly same perspective. Think about this origin. As this one's going to move up 1, right 1. Move 2 is going to be 4. So it's going to be like this. So now we're going to base everything about this graph because we're going to talk about a lot of things about this graph, and you're going to be like kind of like, wow, this is so many things. So first of all, this graph. Now we're going to talk about what is a domain and range. Everybody hates a domain and range, right? And so a lot of you guys just say, oh yeah, it's all real number. If I put all real number, usually half of the time it's going to be right. What a domain and range. But domain and range is actually very easy. So we're going to say domain and range of these functions. Right now, currently, domain of function is going to be what?
All real numbers.
All real number, good. So it's going to be negative infinity to infinity. Because basically graph's going to be extensive. So you're going to domain, you're going to take the marker and you're going to check if they scan through the whole thing. Because the graph keep on going, you're going to intersect at all points. Your range is going to be what?
The y values.
What is it, y?
Yeah.
What is it?
Oh, wait, you asked what it is?
Range.
Hold on.
2.
The y values. And then pod 2 comma infinity.
No, 2. Because it's on.
Yeah.
So you're going to scan this way, right? You're taking a pencil, you're going to scan. Do you intersect any points here?
No.
And when you intersect is when it start.
Two.
Right here, right? So is that including 2 or not including 2?
Included.
It's closed.
2 to infinity. So that's a domain range. Are we okay here?
Yeah.
but there's a slight issue. If I were to have inverse function of this one, can I have an inverse?
No, because
Have an inverse of main range.
No, if I just want to inverse this functions. So we cannot have an inverse function.
it's not.
What's the two condition
It's
to
not monotonic.
have an inverse?
It's not monotonic.
Monotonic and what?
The horizontal line.
Horizontal line test. So am I passing horizontal line test?
Nope.
Nope.
No. So it's not monotonic because it's not only decreasing and it's not only increasing. So it's actually decreasing, increasing. See, this is a failed horizontal line test, and not only that, it's not monotonic. So it's not monotonic. There's got to be something to do with this. Yesterday I said you're not allowed to have inverse. Now I want you to go back to yesterday's notes. I want you to change that. If you fail horizontal line test, it needs restriction on the graph. If I restrict it in a certain way, then I can have an inverse. Okay? If I restrict it in a certain way, I can have inverse. But how do I restrict it? If I restrict it where this function is only strictly increasing or strictly decreasing, it's okay. So how do I restrict it this way? How would I restrict these functions? If I were to do something like a brace in the back, what do I restrict? Yes.
You restrict all the values that are past the vertex of the other.
Yes, past vertex. So that's what we talk about the axial symmetry. It's very important, right? I want to restrict just this part. Does that make sense? Because that way, if I erase the certain way, I'm gonna fail horizontal line test. But the only way is I can cut this graph to half. Because if I cut this graph to half, and then that becomes just like this,
So it's strictly increasing.
and just strictly increasing. Because if I have a little bit of here, and still fail horizontal line test, there's a decreasing, there's increasing.
Mhm.
So I have to erase to the certain part. Am I losing somebody here? I have to cut the graph where it's only increased in order to have inverse. Then I'm gonna modify my domain. How do I modify my domain in this case? If I were to restrict in this case, well, how would I modify the domain? One to infinity, but is that including one?
Yes.
So in order to have inverse, it must be 1 to infinity. So it's going to 1 to infinity, including 1, because we're gonna scan this way, but we don't want anything on this side of the graph. We just want this side and go up. So we change that domain. Yes.
Why does it have to be strictly increasing only?
We're gonna show you in a second.
Okay.
Because we can show you the actual graph because it's better than I can draw.
Okay.
So, question about this part. Question about this part. Okay, so if you look at this, you say, okay, now I can have an inverse. So now I'm gonna find the inverse function. So we're gonna say this is f of x is equal to x minus 1 squared plus 2. We're gonna say that's y. So y, and I'm gonna find the inverse x equal to what? Y minus 1 squared plus 2, right?
Yes.
I swap them, and can I solve for y?
Yeah.
Yeah.
Technically I can. So how do I solve for y? What do I have to do first?
Expand the y minus 1.
No, not expand the y.
Switch it.
Move the 2 to the other side. So I'm gonna get y minus 1 squared equal to x minus 2. And I'm gonna what? Square root both sides, but don't forget about square root both sides. What we're gonna do?
Add the plus or minus.
Thank you. And then we're gonna say y equal to, I'm gonna say not y, I'm gonna say f inverse, because we don't have room, is equal to 1 plus minus square root of x minus 2. Question about this part? I just just simple solving for y, and that's gonna be like this. Question about this? It's difficult? But don't forget about plus minus though, because plus minus is important. Now we're gonna talk about plus minus is important. So those of you guys are gonna learn how to graph square root graph. The square root graph is gonna look like a half problem. It kind of look like a sideways, a quarter, a football. So you're gonna go into that. So we're gonna talk about those. So that means my square root graph is gonna move right 2 units and up 1 units. Okay. Right 2 units and up 1 unit. So it's gonna be like this. And it's gonna be a sideways, it's gonna be like this. Okay, it's gonna be sideways, but it's gonna be this way because it's plus minus. So it's gonna look like this. Okay, so that's why it's plus minus. However, you say, hey, this was original, I have to restrict this way in order to have a inverse. So what I have to do with the domain and range on the new functions? Yeah, domain and range as well, yes.
How did you get the shape?
Okay, so right now, don't worry about it because we're gonna cover it next week. But just know it's a plus one, it's not gonna be the top. So this one is gonna be 1 plus square root x minus 1. This is just gonna be the top. And this bottom is gonna be 1 minus x squared minus 2. Okay, so this top part is gonna belong to here, and this bottom part is belong to here. So if both combinations, it's gonna be like a parabola. Okay. A good question, by the way. But we haven't get there. We'll kind of give you a preview, but you don't have to be able to graph it on the test. You just have to understand the concept related to it. Okay. So you're gonna get 1 plus minus, right? So what is this domain? Domain of the inverse, right? So we're gonna say inverse on this. So f inverse of x, that's equal to 1 plus minus square root of x minus 2. But domain is gonna switch. Domain and range is gonna be what? Swap. Right, 2 comma infinity. Right? And then there's gonna be 1 comma infinity. So the range, look at the range though. Domain is still going from here to here, right? So 2 to infinity, right?
Yeah.
But look at the range. Range, they want to cut off from 1 to infinity. So 1 to infinity, that means going from here and up, yes. Okay, so here and up. So then I can go in to exclude one part of the equation. I can go in to exclude this part. I can cross this part out. I can say, hey, I don't want this part. And I just want it equal to 1 plus square root of x minus 2. So that becomes a true inverse of this one with the restriction and proper restriction to the other side. So I know this is so much for you to handle if you guys don't have a good algebra background, but here's the idea. The main idea I want you to understand is the domain and range is swapping as well, besides the coordinate swap. So write down in yesterday's notes as coordinate swap, also including domain and range is gonna swap as well. So if you swap those, they swap at the same time. That way I can eliminate into a proper equation to do a proper thing. So that's a little bit a big idea for what I want students to get, is to see that domain range also swap, and besides the coordinate, the reflection, everything, and we're gonna show you how this actually works. Am I going too fast? So the main idea, domain range swap as well. That way I can restrict to understand it's not plus minus, it's just the plus, just the top part. And the top part is very essentially important for a lot of students to understand. I know this is probably one of the first time we introduce complex things, and there's a lot of things to digest, but it's okay. You digest the big picture first, and you say, okay, this is what generalized is gonna be. Then you start to understand little details, so the details kind of flop and then transfer, and that's why you exclude the bottom part of the graph. So now I can exclude this. So now what do you see?
Wow.
Before you don't see that, right? You have this, right? So there is not symmetry, it's not exactly symmetry. So then you can go in, you can say, hey, now I have the symmetry that we were talking about, the symmetry y equal to x. And that's very essential for students to understand. Now I can actually truly have inverse. And this happened in sine, inverse sine, cosine, inverse cosine, logarithms, and e to the x. This idea keep on repeating over and over again. Well, that's what makes us special is we are studying those things in a more intricate level now. We're studying the same thing as before. Before you covered logarithm exponential equation, but now we cover the same thing. Like 4th grade, we learned water has 3 forms, right? Ice, solid, gas, and liquid, right? And then in the high school, in the middle school, we learned that it's H2O. Oh, what is H2O, right?
I do.
And then in high school, we learned like, okay, it's H2O. No. Now there's a hydrogen, a hydrogen peroxide, hydrogen oxide. So it's a H positive and OH minus. And then H positive is the acid part, and the OH is the base part. And the combination, if they have the same equal strength, then you got water exactly at pH of 7. What is pH? pH is 7. pH is 7 means neutral. If pH is higher, that means more hydrogen. pH is lower, that means more hydrogen. pH is higher, that means there's no hydrogen oxide. And then you guys see all those things, and you can see Ka, Kb, Kw. You can see all those changes. All those changes are very, very small. So we're learning still the same thing, but we're learning much more detail than before. Okay, much more detail than before. Now, the bridge swap. So let me show you a picture. Instead of my ugly drawing, I'm going to show you what a computer drawing is like. So it's okay, everybody's right. It's on the YouTube. So you can always subscribe me, like, and comment.
I like how you took that chance to nerd out about chemistry.
Huh?
I like how you took that chance to nerd out about chemistry.
Oh, I'm a chemistry major.
Yeah.
So I love the chemistry part of
Can you be a
mathematics.
chemistry teacher? Please.
Please. Tutor us in chemistry.
Please.
Okay, so this is the original graph without restriction, and this is the inverse, but inverse has 2 different ones, right?
Yeah.
And but that's not exactly inverse because the green part is not matching. So we had to get rid of the green part to have the inverse. Now some people says, what if I cut the graph the other way? You can. So I'm gonna get rid of this. I'm gonna cut the graph the other way, to this way, right? And then I'm gonna, domain and range is gonna swap. So therefore, I'm gonna cut it to the bottom part of the function. Now you can have an inverse.
Wow.
But if it's simultaneously, they're not really exact inverse to each other. It's only half is half are inverse to each other, the other half is inverse function, but not both inverse at the same exact time.
That looks pretty cool.
That's why you needed to have pass horizontal line test. That's why you needed to do anything like this. Okay. Conceptually, this is a very difficult, but ideally, we're gonna go into deeper when we go to, again, it happened to so many times that what we're gonna study about inverse. That's why I spent 3 days on inverse. It was not a hard concept. Switch x and y, solve for y, yeah. But the concept behind the whole thing, that what makes precalculus run is really here. And that's why I spent a lot of time to talk it. Am I gonna test this? Not entirely. But the idea, the base idea that when you talk about precalc, you really understand this. Okay. Got it?
Yes.
Indeed.
Indeed. How about give you one?
What?
Yes.
I'll try.
Sure.
Go. Try. Do it.
We can try.
I give you.
Okay, so I'm gonna give you the graph first.
If I get it right, can I get $10?
No. You got it wrong, you only win $10.
No.
So,
If I get it right, can I get crackers?
why you guys negotiate me while I'm on a YouTube live stream? Okay, so I want you to find the inverse and with the correct restrictions. Now, I'm gonna help you with the graph on this one. The graph is gonna look like 1, 2, 3, 4, and down 2. So it's gonna look something like this. So that's the graph. So that way you can see that restriction is supposed to be. Then you can restrict the other side. So let's look at the other side as well. So I want you to find the inverse of that function with the correct restrictions. With the correct restrictions. And graph it. I already graphed the radical for you. Today your homework is gonna be what's gonna be on Tuesday's test. And then you have to make sure you get it done. It's a homework, it's a review, but it's also a homework.
Yes,
Some
sir.
people say, oh yeah, review is not homework. No, review is the homework.
Benjamin.
Huh?
Benjamin.
I don't know what you're talking about.
I didn't sleep until 6 o'clock in the morning.
You know what? I might just, no, I'm not gonna hold over that.
I didn't sleep, I swear. I couldn't think on the test day. That's why I get a 56.
You know what? It actually was true, so I'm unbothered.
Unbothered.
I'm unbothered.
What kind of English is that? Unbothered.
Monsieur, don't be talking about English now. Let's see, look, what is that YouTube subscription?
Yeah, I do. I was helping my son the other day, and I'm trying to teach him so what is a fragment, right?
Mhm.
It's a difficult. There's a subject and there's a predicate. I'm like, what the hell does a predicate mean? What does a predicate mean? So I had to look it up. So what the hell is a predicate? And I was like, yeah, it was so difficult for me. And basically it was an idea. So end up I come up with an example, but just think about it. Buckle your seatbelt. Is that a complete sentence?
And put it
Yeah, period. Buckle your seatbelt, period. Or exclamation mark. Is that a sentence?
I would say.
Supposedly, I guess.
So what is the subject?
Oh,
yeah.
Oh.
What is the verb?
Buckle.
But who is
Who's doing it? Who's doing
who is
it?
doing that?
Your. So the person that you're.
No, it didn't say. It said buckle your seatbelt. Huh?
You are the subject.
There's no you. There's no you
Say
there.
your. Buckle your.
What do you mean it imply?
Yours.
Buckle your.
What kind of thing is
He
this?
said buckle your.
Okay, you need to buckle your seatbelt. Then that's a complete sentence. But buckle your seatbelt, that's not a complete sentence. How is that it?
Yours. It's telling you to buckle your seatbelt. Buckle your seatbelt.
Yeah, because you're saying buckle
Where's
your.
the? But there's no you.
It's in yours.
Okay,
Yours.
well, you know what? As far as conversational English goes, it's a complete sentence because if you're speaking to someone, you're having a conversation. You're saying buckle your seatbelt. Your implies that you're directing the action towards them. So buckle your seatbelt. It makes sense.
I mean, it makes sense.
Yeah, there we go. Josephine, buckle your seatbelt. That's a complete sentence.
You know, like, it's also in Spanish too. You can say the verb without the subject in the beginning because the verb is conjugated in the way, like, of the thing.
So we're like, is that a fragment? It's a complete sentence. We
Yes.
don't know.
It is.
Buckle your
Complete
seatbelt.
sentence? Oh, yeah, it is. Yeah, it's a complete sentence.
It's a complete sentence.
Yes. It's the imaginary units. This is like an actual thing that exists.
I hate English.